All right. Good evening, everyone. Good evening, Ankit, Danush, Varsha, Sakshi, Saksha, Chetna, Pritesh, Lasya, Khushi, Chaitra, Meghna, Ruchi, Sanjana, Monisha, Ganesh, Chetan, Vasavraj. Good evening, guys. Good evening, Danush. Good evening, Anisha. Right. So this is the usual scenario. I don't know nowadays. It's done. E, I have kind of cropped it. It's done. So I don't know whether you guys have done the projects in schools or not, but when I was in my school, there used to be a lot of group projects. So that was a usual scenario, and I was the one who will appear only on the day of the exhibition of the project. Most of the work was done by one of our friends, so I found it quite relatable. So this is one. Chalo. Good evening, PK. Good evening, Gokul. Good evening, Muktamani. Yes. So let's start without much delay. We start one day before. One day is actually depends on the project, but one day is not sufficient. Depends on the project. Well, nowadays everything is changing, so we can't say. When I was in school, to make a floppy cup PowerPoint presentation and save it in floppy and submit it to school was also a big challenge for us because at that time not everyone used to have computer. Rarely you'll find computer in people's house. You have to go to cafe. You don't know floppy disk. It was a storage device. It was a secondary storage device. So it was not like some everybody has uh, PCs at their house. Rarely people will have. Yeah, like pen drive. Correct. तो इसीलिए it was not that easy. So yeah, अभी तो everything is digital. Like you have everything in front of you. You are learning on PCs. You are learning on phones, tablets, etc., etc. Chalo then, let's move ahead. Let's move ahead. We'll start with a recall test question on last class. If what is true about H2SNO6? If you remember last class, I taught you about dithionic acid. In one of the recall tests, we discussed dithionic acid. If instead of dithionic acid, you have polythionic acid, right? We had done H2S2O6. It is H2SNO6. So what is true about dithionic acid? What is true about dithionic acid? Which of the following is true about dithionic acid? Draw the structure and solve. If you try to guess it, you will not get anything. Put the value of N and check. You can put the value of N and solve. You'll get the answer. Put the value of N and solve, and you'll get the answer. Yes, you can start voting. I don't know how many of you got the right answer. Just put the value of n and solve. You'll get the answer. You can rule out the options. You can solve it from options. We'll see, Pritesh. Chalo, I'll give you another 10 seconds to vote. Not more than that. All right, let's end it then on a count of 3, 2, 1. Let's end it now. Yes. So if you see this, let us put N as 2. So if you take H2S2O6 dithionic acid, so sulfur double bond O, double bond O, sulfur double bond O, double bond O, sulfur sulfur single bond, OH, OH. This is the structure of dithionic acid. Here your N is 2. If your N is 2, how many sulfur sulfur bonds are there? How many sulfur sulfur bonds are there? 1. So number of sulfur sulfur bond is 1, whereas N is 2. So obviously for N atoms, number of sulfur sulfur bond is not N. So obviously A is wrong. A is wrong. Now sulfur atom with number of sulfur with 0 oxidation state is N minus 1. Check how many sulfur are there with 0 oxidation state. This sulfur has how much oxidation state? -2, -2, +2, +2, -1, +1. So this is +5. This will also come out to be +5. Correct? So number of sulfur with 0 oxidation state is not N minus 1. If your N is 2, if N minus 1 is 1. So do you have even one sulfur atom with 0 oxidation state? No. So B is also wrong. Now check option D. So +5 oxidation state ke you have N minus 2 atom. So if you have N as 2, N minus 2 will be what? 0. But how many sulfur +5 you have? 2. So 2 sulfur in +5, not 0. So again C is also wrong. Check option D. Option D may it is saying p pi d pi bonds are 4. So first check the pi bonds. There are 4 pi bonds. Pi, 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 pi. 4 pi bonds. Now this pi bond is formed by d orbital of sulfur and p orbital of oxygen. So all these pi bonds are p pi d pi bond. So you'll say there are 4 p pi d pi bonds. That is correct. So your correct answer here is D. Correct answer here is D. The correct answer here is D. Okay. Is that clear, everyone? Anyone having any doubt in this? Anyone having any doubt in this? Chal, let's move ahead. So we were discussing about group 17. We were discussing about group 17. So we were discussing about oxidation state mainly. And I had told you they, right. So I had told you they can show oxidation state of +3, +5, +7 oxidation states. Right? These are the possible oxidation states shown by group 17 elements. Right? Now this is important. The higher oxidation state of chlorine, bromine, and iodine are observed when the halogens are in combination with small and highly electronegative atom like fluorine and oxygen atom. So mostly you will see +5 and +7 oxidation state only in oxides and fluorides. So oxides and fluorides may you will see +5 and +7 oxidation state. Why? Because to excite this electron, you need strong electronegative groups. Only strong electronegative groups can excite this electron. Okay? Now, all the halogens are highly reactive. They react with metals and non-metals to form halide. The reactivity of the halogen decreases down the group. We all know reactivity of halogen decreases down the group. Can anybody tell me the reason why halogen reactivity decreases down the group? Why halogen reactivity decreases down the group? Anyone? Halogens are non-metals. Non-metal have tendency to gain electron. Down the group, size increases. Tendency to gain electron is what? Tendency to gain electron is what? Electron affinity. Right? Electron affinity. So non-metals tendency to gain electron or electron affinity decreases down the group. Therefore, their reactivity decreases down the group. Okay? So you can write the reason if you want, because electron affinity decreases down the group. Okay? All right. Just a minute. I'm just hoping you guys are sitting with textbooks, marking each and every important line. I'm just hoping that, right? Now, if you move ahead, the ready acceptance of electron is the reason for the strong oxidizing nature of halogens. Fluorine is the strongest oxidizing agent. We have already discussed this yesterday, and it oxidizes other halide ions in solution and even in the solid phase, right? So fluorine is a very strong oxidizing agent. So fluorine can oxidize other halide ion like Cl minus, Br minus, right? So if you react fluorine with Cl minus will get oxidized to Cl2 and fluorine will get reduced to F minus. So fluorine is strongest oxidizing agent. So it can oxidize either Cl minus, Br minus or I minus. Okay? So it will be like this. Ki strong electronegative element will oxidize less electronegative element. You can remember it like this. Strong electronegative element oxidize less electronegative element. Oxidize less electronegative element. So for example, bromine and iodine mein bromine is more electronegative. So bromine is oxidizing I minus to I2. And itself it is getting reduced from 0 to -1. That is the whole point here. Okay? The decreasing oxidizing power of the halogen in aqueous solution down the group is evident that from their reduction potential. I have already shown you their reduction potential. The maximum reduction potential is for fluorine. We have already seen their reduction potential values. If you want, I can show you again. This was the table where we had seen their reduction potential values. Sorry, I think it has gone again. I don't know why it is happening. Yeah, you can see fluorine has highest, then it decreases down the group. So since the reduction potential decreases down the group, you can say, what's the problem? No, it's not like that. So this is what I wanted to tell. As the reduction potential decreases down the group, oxidizing power oxidizing power also decreases. Right. So we were discussing this. Yeah. So this is all about oxidizing nature and oxidation state of. Yo. Just a minute, guys. Give me 1 minute. Actually, 3-4 minutes. Just 1 minute. I hope there should be no problem now. Yes. All of you are able to hear me, right? Chalo, let's move ahead. Right. So we have already discussed their oxidizing power, right? So the relative oxidizing power of halogens can further be illustrated by the reaction with water. This is very, very important. Reaction of halogen with water. As I said, these are very important reactions. Halogens with water, right? So if you see fluorine ka reaction with water, mark kar lo, this is very important. Fluorine ka reaction with water, you'll get F minus plus O2 gas. H plus F minus plus O2 gas. You'll get this. Other halogen, whether it is chlorine, bromine, or iodine, chlorine or bromine, it reacts with water to give you HX. See, it is also HX. Fluorine is reacting to give you HF, right? You're getting HF here, you're getting HX here. Same thing. But here you get O2 and here you get HOX. For example, chlorine, if you react it with water, you'll get HCl plus HOCl. HCl plus HOCl. Okay? Iodine will also react with water to give you 4Hi plus O2. Okay? So fluorine or iodine react in a similar manner. Fluorine and iodine react in a similar manner, whereas chlorine and bromine react in a similar manner with water. Okay? Now, if you see this carefully, halogen oxidation state, for example, chlorine is 0, -1. Chlorine here will come out to be +1. So 0 to -1 reduction, 0 to +1 oxidation. That means chlorine will undergo disproportionation reaction on reaction with water. You'll get HCl and HOCl. Whereas fluorine and iodine on oxidation with water gives you O2, right? And the reaction is reversible. With iodine, the reaction is reversible. Okay? Yes. Is that clear, everyone? Is that clear, everyone? This reaction is very important. Please mark it in your book. This reaction is very important. Please mark it in your book. Right. Let's move ahead. So if you see anomalous behavior of fluorine, like other elements of P block in the second period, fluorine is the anomalous. Fluorine shows anomalous properties. Reasons are same: small size, high electronegativity, empty d orbitals. So high ionization enthalpy, high electronegativity, high reduction potential. All other or in or fluorine. Just a minute. For fluorine, than expected from other halogens. So what we are trying to say here, we are trying to say fluorine because it has high ionization enthalpy, it has high electronegativity, high electrode potential, reduction potential is 2.52. It shows anomalous properties other than chlorine, bromine, and iodine. It shows different properties from these elements. Also, ionic and covalent radii, melting point, boiling point, enthalpy. This is important. Fluorine ka bond dissociation enthalpy is very low. Bond enthalpy of bond dissociation and electron gain enthalpy are quite lower than expected. Bond dissociation enthalpy, you can check the table, 2.87 or 2.5. I don't know exact value. It is 2 point something. So all these bond dissociation enthalpy is also low, right? Because of electron-electron repulsion. The anomalous behavior of fluorine is due to its small size, high electronegativity, low fluorine bond dissociation enthalpy, non-availability of d orbitals. Now, this is a very important statement. Please say this. Most of the reactions of fluorine are exothermic. Question यही आएगा. Most of the reactions of fluorine are exothermic. Reason? Why? Option will be fluorine is more electronegative. Fluorine has high ionization energy. Fluorine has no vacant d orbitals. So fluorine has all of this, but that is not the reason. The reason for exothermic reactions are due to small and strong bond formed by it with other elements. Because fluorine have tendency to form strong and short bonds with other element. Okay? If I remember correct, when I was in my 12th CBSE board, this was the statement which was asked. You can check. I think 2011 mein. CBSE ka chemistry paper mein, you can say, check this statement was asked from the textbook. Reason. I was knowing the reason because I have read every line of textbook at that time. Okay? So because the reason is because fluorine can form short and strong bonds with other elements. That's why its reactions are exothermic. Okay? Now, it forms only one oxo acid. It forms, I told you, right? Fluorine forms only one oxo acid with other halogens form number of oxo acid. Okay? If you see chlorine can form lot of oxo acids like HOCl, HClO2, HClO4, but fluorine form only one oxo acid, that is HOF. Actually, देखो logic क्या है? Oxo acid में halogen will have positive oxidation state. Halogen will have positive oxidation state. But we know fluorine cannot have positive oxidation rate because it is most electronegative element. So how fluorine can form oxo acids? So that's the reason fluorine do not form oxo acid. It was studied earlier. Earlier we used to say fluorine do not form oxo acids. But later it was realized that fluorine can form one oxo acid, that is HOF. Okay? We'll come back to it. Whereas other elements can form more than one oxo acid. HClO2, HClO, HClO3, HClO4. Lot of oxo acids are possible, but fluorine will form only one HOF. Okay? Because it is highly electronegative. So it can't show positive oxidation state. Okay? Remember this. This is very, 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 very important. Okay? Now reactivity towards hydrogen. Same thing. Halogens are showing negative oxidation state of -1. Halogens show negative oxidation state of -1. Hydrogen +1. So if you combine them, they form hydrides of general formula HX, where X can be chlorine, bromine, iodine. They form halides of general formula HX, right? Now, if they form halides of general formula HX, HCl, HBr, HF, HI, fluorine can also be there. So hydride में same property, melting point, boiling point, thermal stability, acidic character, reducing character, everything same, no change. Whatever you studied there, almost same thing here. Melting point decreases down the group between HCl and HF, and then it increases. Only HCl may decreases, rest it only HCl is too low, otherwise, or you can generally say melting point increases down the group. You can say melting point increases down the group. HF is an exception. Similarly, boiling point increases down the group. HF is an exception. So HF is an exception in both the graphs. So you'll get HF on top, right? In the boiling point graph, HF will be on top. Rest everything, HCl, HBr, HI, all will be bottom. Okay? So HF will have maximum boiling point due to hydrogen bonding. Bond length, obviously, as size increases, HF bond is small, HCl bond is large, size increases, HBr bond is high, HI bond is longest. So as size increases, bond length increases. Longer bonds are weaker bonds, so it requires less energy to break them. Since HI bond is long bond, its bond energy will be less. So bond energy decreases, right? Now all of them behave as acids. All of them behave as acids. Now we have already studied it before among HF, HCl, HBr, HI. Which is stronger acid? What is the order of acidic character? Which is stronger acid? What is the order of acidic character? Which is stronger acid? Down the group, acidic character increases because bond length increases. So if HI is strong acid, so we know acidic character is inversely proportional, directly proportional to Ka, inversely proportional to Pk. So since HI is a stronger acid, acidic character is more, Pk will be less. So for HI, Pk is least. For HF, it is a weak acid. Weak acid means acidic character is less. Weak acid means acidic character is less. So Pk will be more. So they can even ask you the order of Pk. Right? That's all. We have done this all in the other groups also. Reactivity towards oxygen. So all of them, halogens form many oxides with oxygen, but most of them are unstable. Fluorine form two type of oxides, OF2 and O2F2. In OF2, oxygen shows +2, and O2F2, it shows +1. It was there in last year also. Okay, in redox. However, only OF2 is thermally stable at 298 Kelvin. At 298 Kelvin room temperature, only OF2 is stable. Right? These oxides are essentially oxygen fluorides. That means oxygen can form oxides with fluorine only. So they are not called oxides, they are called fluorides. So OF2 will not be said oxide of fluorine. It will be said fluoride of oxygen because fluorine is more electronegative, right? They are essentially called oxygen fluorides because of the higher electronegativity of fluorine than oxygen. Both are strong fluorinating agents. O2F2 oxidizes PuF6 and their reaction is used involving removing plutonium as PuF6 from nuclear fuel. So if you want to remove plutonium from nuclear fuel, you will treat PuF6 with OF2, right? It will release plutonium. It will release all plutonium because fluoride will be absorbed by OF2. Okay? In different forms. So what we are trying to say here, they are strong fluorinating agent. They oxidizes PuF6, right? PuF6 they can oxidize to Pu, and the reaction is used for removing plutonium from PuF6 in nuclear reactors. Chlorine, bromine, and iodine form oxides in the oxidation states that range from +1 to +7. They can form oxide in the range of in the oxidation state of +1 to +7. A combination of kinetic and thermodynamic factors lead to the decreasing stability of oxides by halogens. That means iodine oxides are more stable than chlorine, than bromine. Now, this is very, very important from your competitive exam point of view. If they give you IO2, ClO2, and BrO2, they may ask you the order of stability. So you'll say IO2 is more stable, then ClO2, then BrO2. ठीक है. IO2 is more stable because IO bond is more polar. Down the group, polarity increases. So IO bond is more polar. It is more polar. ठीक है. So that's the reason IO bond is more polar. Now among CLO bond is more polar, more stable than Br2O bond because of Cl can donate lone pair into the empty d orbital, and there can be a possibility of back bonding. Therefore, ClO2 is more stable in than BrO2 because Br ka size is large, so back bonding will not be possible. So you can write here, this is more stable due to back bonding, and you can write here, this is more stable because it is more polar. IO2 is more polar. So this is very important exception. Please remember this. This is really very important. Okay. So chlorine oxides are Cl2O, ClO2, Cl2O6, Cl2O7. So this is oxidation state +1, +4, +3, +5, +7. Just check. 2x minus 12 equal to 0. It will be +6. And 2x, it should be -1 actually. X minus 4, हाँ. Oxidation state should be +4 and +6, na? It should be +4 and +6. So just check, there should be a minus also. Bromine can form oxides like Br2O, BrO2, BrO3. And the least stable halogen oxides, it's middle row anomaly. Bromine oxide is the least stable, and bromine oxides are the least stable. Bromine oxides are least stable oxides. I have given you the reason. They say it is middle row anomaly, but I have given you the reason why bromine oxides are least stable. Okay? And exist only at low temperature. They are very powerful oxidizing agents. So bromine compounds are very powerful oxidizing agents. Right? Now iodine can form I2O4, I2O5, I2O7. These are insoluble solids and decompose on heating. I2O5 is very good oxidizing agent and is used in elimination of carbon monoxide. It is used in elimination of carbon monoxide. Now, if you talk about reactivity towards metal, you have already discussed this. Magnesium can react with halogen bromine to form magnesium bromide. The ionic character of halide decreases from fluoride, then chloride, then bromide, then iodide. So why fluorides are more ionic than iodides? Why iodides are least ionic? What would you say? Why fluorides are more ionic? Why fluorides are more ionic? Yes, because I minus ka size is large. Larger the size of anion, larger the size of anion, larger the size of anion, more is the covalent character because more is the polarization. So larger is the size of an ion, more is the polarization, more is covalent character. This is from Fejan's rule. Okay? So you can apply the same concept here also. Now, if you see the next sentence, this is done from Fejan's rule. You can write it here. It is from Fejan's rule. Now, if you see, if a metal exhibits more than one oxidation state, the halides in higher oxidation state will be more covalent. We all know this. The halides in higher oxidation state will be more covalent than the one in the lower oxidation state. For example, tin chloride, PbCl4, SbCl5, UF6 are more covalent than SnCl2, PbCl2, SbCl3, UF4. So we also know this. As the positive charge increases, polarizing power increases. Polarizing power increases, polarization increases, covalent character increases. So you can say again, this can be explained from Fejan's rule. Okay? Now reactivity towards halogen. This is very, very important. So halogens, when they react with halogens, they form something called interhalogen compound. Right? So interhalogen compound. Halogens combine with themselves to form a compound called known as interhalogen compounds. Right? They can form interhalogen compounds. What are the general formulas? XX-1, XX-3, XX-5, XX-7. Why only these? Because halogen can show +1, +3, +5, +7. So halogen can show these oxygen states. So their interhalogen compounds will also be in these oxygen state. So if it is in +1, so it will be XX dash. If it is in +3, XX dash 3. If it is in +5, XX dash 5. If it is in +7, XX dash 7. Where X is the larger halogen and X dash is the smaller halogen according to size. X is the larger halogen and X dash is the smaller halogen. Please check this carefully. If there is any doubt, quickly ask. We are done with this. We'll move ahead with the table of in which state they will exist. Which state matlab? Karnataka mein they will exist. Pritesh, which state matlab? Solid, liquid or gas? That depends upon individual compound. That's not general. That is the property of the compound. From a different interhalogen to different interhalogen, it varies. Now, check this. Yeah. So if I give you interhalogen compounds ki examples, if you take X, X dash, let me check if I have a table here. No. Just a minute. Let me check if I have a table here from textbook. Huh, it's here. See here. If you see this table, properties of interhalogen compounds, X, X dash mein X should be larger, X dash should be smaller. You can take ClF, BrF, IF, BrCl, ICl. Br is larger than Cl, iodine is larger than Cl. Actually, X dash should be more electronegative, to be honest. X dash, electronegativity of X dash should be greater than electronegativity of X. Okay? So you can see fluorine is more electronegative than chlorine, bromine more than fluorine more than bromine, fluorine more than iodine, chlorine more electronegative than bromine. Right? So these are the interhalogen compounds. XX dash ka 3 ka example be ClF3, BrF3, IF3, ICl3. So again, you can see second elements are less electronegative than first elements. Then XX dash mein IF5, BrF5, ClF5, XX dash 7 mein IF7. So these are the different examples of interhalogen compounds. Now you can see it depends upon compound to compound whether there will be colorless gas, ClF, BrF is pale brown gas, IF is detected by spectroscopy, ICl is ruby red solid, alpha form, beta form. So what color they will show, they will exist in different color depending upon their properties. Right? So these are their different colors and properties. You may go through it. It's not, you're not supposed to by heart it, but still you can go through it. What is important is their structures. So X dash is linear because there are already 2 atoms. Baki you can check ClF3, you can check IF5, you can check IF7. So if you check ClF3, chlorine 7 valence electron, fluorine 3. Fluorine 7 valence electron into 3. So 21 plus 7, 28 electrons are there. 28 total electrons are there. So you divide it by 8. So you get quotient as 3, remainder as 4, divided by 2 again, quotient 2. So 3 bond pair, 2 lone pair. 3 bond pair, 2 lone pair. Your hybridization will be sp3d, right? sp3d mein matlab geometry will be pvp, pentagonal bipyramidal. Okay? It is pentagonal bipyramidal. In pentagonal bipyramidal, lone pair goes on equatorial. So we are doing what? We are doing ClF3. Cl, F, 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 F. So ClF3 mein lone pair goes on axial. Sorry, electronegative atom on axial. Lone pair goes on equatorial position. So you can see it looks like a T. Therefore, it is given a T-shaped. Therefore, it is given a name T-shaped. Similarly, if you try for IF5, it will be square pyramidal. And IF7 will be pentagonal bipyramidal. I'll give you the example of both. Right. IF5. Can you calculate its hybridization and tell me its hybridization? What is hybridization of IF5? Can you calculate and tell me its hybridization? Iodine का 7 electrons, fluorine का 7 into 5, 35 plus 7 42, divide by 8, 5 पे 40, remainder 2, divided by 2 again 1. So 5 bond pair, 1 lone pair, right? So hybridization is 5 plus 1 6, sp3d2. So sp3d2 में geometry is sp3d2 में geometry is what? Octahedral, right? Octahedral. So if it is octahedral, there are 6 positions. One will be occupied by lone pair because there is one lone pair, 5 bond pair. Remaining 5 will be occupied by fluorine. And its shape, octahedral geometry. Geometry is octahedral and shape is pyramidal. Square pyramidal. Shape is square pyramidal. Okay. So this is your IF5. Similarly, you can do IF7. 7 plus 7 into 7, 49. 56 by 2 by 8. You'll get 6. 48. 49. Yeah, 56 divided by 8. 54 you'll get. 54 you'll get 2 remainder. Divided by 2 again. So 6 bond pair, 1 lone pair. 6 bond pair, 1 lone pair. So if you get 6 bond pair, 1 lone pair, then again its hybridization is 6 plus 1 7, sp3d2. sp3d2 hybridization. If its hybridization is sp3d2, its geometry is octahedral. And how will its shape look like? There is a pentagon. There is a center में IFF7, and then there is a 1 fluorine up, 1 fluorine down. 1 fluorine up, 1 fluorine down. So this is a pentagonal bipyramidal. अच्छा, it is 7 क्या? 8 7. हाँ, it is exactly divisible. Sorry, I took it as 54. It is 7. So 7 pair hybridization will be sp3d2. ठीक है, 0 lone pair. There is no lone pair with iodine. All 7 bond pairs. All 7 bond pairs. So you can see any interhalogen compound का shape you can determine, and its hybridization will become sp3d3. sp3d3. 3 plus 3 plus 1 7. Right, and its shape will be known as pentagonal bipyramidal. Pentagonal bipyramidal. And if there is a lone pair here in this 7, if you have 6 bond pair and 1 lone pair, 6 bond pair and 1 lone pair, then it is known as sp3d3 hybridization. Geometry octahedral. Geometry is also not octahedral now. Geometry is pentagonal bipyramidal. Geometry is pentagonal bipyramidal. So geometry will remain same. If you get 6 bond pair and 1 lone pair, geometry will remain same. Shape will become geometry will remain same. If you get 6 bond pair and 1 lone pair, geometry will remain same. Shape will become distorted octahedral. It will become distorted octahedral. Okay. That's what I said, Gokul. It can have 6 bond pair. I will write it here for you. If it gets 6 bond pair, XCF6 is the example. You can try it. 6 bond pair, 1 lone pair. Geometry hybridization is same, sp3d3. Geometry is same, pentagonal bipyramidal. Shape will be distorted octahedral. We'll discuss it in group 18. ठीक है? So this is your interhalogen compounds. Anyone having any doubt in this? Please ask quickly. If anyone having any doubt in this, please ask quickly. If I3 hybridization is not clear, why not sp3d3? I didn't get your point, Atha. In XCF6, lone pair is 0. Acha, Pritesh. Check again, Pritesh. Xenon has 8 valence electron, noble gas, 6 bonds. There'll be a lone pair, na? Right. So let's move ahead. Yeah. So we were discussing about this. So we were discussing about, that's because of your name, Pranav. Now, if you see chlorine, in your exam, either you get contact process for boats, okay, or you get Deacon's process by which chlorine is prepared. Haber process you rarely get. So Haber, contact, or Deacon, any one of these processes you can get. So preparation of chlorine, right? It was discovered in 1774 by Scheele by the action of HCl on MnO2. In 1810, Davy established the elementary nature and suggested that name chlorine on the account of its color because it is greenish yellow in color. Right. It can be prepared by the following methods. If you treat MnO2 with HCl, right, you'll get MnCl2. Mn will combine with Cl to form MnCl2. Right. Still there'll be balancing pay. You'll get 4 HCl. So still 2 chlorine will be left. It will be released as 2 chlorine. 4 hydrogen, 2 oxygen will be released as 2H2. Right. It will be released as 2H2. There is no need to by heart this reaction. Right. If you treat it with the MnO2 with the NaCl also, if you treat it with NaCl also instead of HCl, you can still get chlorine and MnCl2 is produced again. Just the difference is when you use NaCl, you'll get extra NaHS4. That's the only difference. Okay? And when you treat it with this reaction, all of you have done, right? In redox, Mn goes from +7 to +2. Mn goes from +7 to +2 reduction. And chlorine goes from -1 to 0 oxidation. Right? It goes from -1 to 0 oxidation. So it is there in your redox also. It is there in D and F block also. So this reaction we have already discussed. Now manufacture of chlorine by Deacon's process. This is also very important for your boards. This is also very important for your boards. Either contact or Deacon will be asked. Now by oxidation of hydrochloride, if you oxidize HCl gas, you'll get Cl2 gas plus water. Right? This is your Deacon's process. There is nothing very difficult in it. Just remember the reaction. Copper chloride is used as catalyst. So electrolytic process say you can prepare chlorine is pacha. Can you prepare electrolysis say Cl2 gas? Can you prepare electrolysis say Cl2 gas? Yes. If you do NaCl ka electrolysis, molten NaCl, Cl minus goes to anode. Anode pe Cl minus goes, and Cl minus release what? Cl2. Okay. So if you do the electrolysis of NaCl, Cl minus will go to anode and undergo oxidation to give you chlorine gas. Okay. So it can be prepared by this method also. Right. Now coming to its properties. It is greenish yellow gas with pungent and suffocating smell. You must have got this gas while doing practicals. It is about 2 to 5 times heavier than air. It can be liquefied easily to greenish yellow liquid and boils at 293 Kelvin and is soluble in water. Now, aluminium ke saath it reacts, it forms AlCl3. Sodium ke saath it reacts, it forms NaCl. Fe ke saath reacts, it forms Cl2. If it reacts with Cl2, you get FeCl3. So basically, chlorine can react with metals as well as non-metal. So if Cl2 reacts with phosphorus, you'll get PCl3. With the sulfur, you'll get H2Cl2. Okay? So these reactions you have already done. It can combine with H2 to form HCl. It can combine with H2S also to form HCl. And chlorine can combine with C10H16. C10H16 to form HCl. Right? So these are different methods of preparation reactions of HCl. Now this is very important for your boards. Again, it is important for your boards. The question will be an ammonia excess with chlorine will be given. So when you take ammonia in excess, chlorine in less amount, you'll get ammonium chloride and N2 gas. If you take ammonia and Cl2 in excess, this is very important. Ammonia with Cl2 in excess, you'll get NCl3 plus HCl. You'll get NCl3 plus HCl. So remember, if ammonia is in excess, you'll get ammonium chloride. If chlorine is in excess, you'll get NCl3 and HCl. Okay. Now these reactions are also very, very important from all exam point of view. So if you treat chlorine with cold and alkaline NaOH, just like chlorine reacts with water to give you HCl and HOCl, similarly chlorine reacts with NaOH to give NaCl and NaOCl. Yeah, you remember this reaction. Chlorine reacts with water to give you HCl plus HOCl, right? Similarly, chlorine will react with NaOH to give you instead of HOCl, you'll get NaOCl. Instead of HCl, you'll get NaCl. That is the only difference. What is the difference with it? Hot and concentrated? Just more oxidized product will be formed. NaCl will remain as it is. Instead of NaOCl, you'll get NaClO3. Right? That's the only difference. So if you take cold dilute alkaline, you'll get NaCl plus NaOCl. If you take concentrated, you'll get NaCl plus NaClO3 both. Okay? With dry, if you treat it with dry lime water, calcium hydroxide, you'll get calcium oxychloride. This is your bleaching agent. This is your bleaching agent or called bleaching powder also. Ammonia reaction is not there in your textbook. How is it possible, man? I am reading out textbook only. I don't know how it is not there in your textbook. If it is not there, please write it. It's very important reaction. If it is not there, please write it. It's very important reaction. All these reactions which I have marked here are important. Cl2 का cold alkaline के साथ NaCl plus NaOCl बनेगा. Hot के साथ just इसका oxidized part. This will get oxidized to NaOCl. This will get oxidized to NaClO3. That's the only difference. You can note it. That's why I'm giving you time to note it. I'm going to change slides so you can take a screenshot with you. If it is not there in your textbook, you can take a screenshot with you. Right? Chalo, let's move ahead. These reactions I'm not going to explain. Halogenation of methane, all of you know much about it. In organic chemistry, you have studied reaction of methane with chlorine, free radical mechanism, right? So reaction of ethane with chlorine or ethene with chlorine, free radical mechanism. So I'm not going to discuss it in detail, right? And this is something where you can chlorine water can be used as oxidizing agent. Chlorine, just now you have seen halogens can be used as oxidizing agents. So see here, chlorine is oxidizing your Fe plus 2 to Fe plus 3. You can do the balancing part, right? And here also chlorine is oxidizing sulfur. Here is SO3 2 minus. Here it becomes SO4 2 minus. Addition of oxygen is oxidation. So chlorine acts as a very good oxidizing agent. So these reaction mein chlorine is acting as oxidizing agent. Chlorine is acting as very good oxidizing agent. Chlorine, when it reacts with water, we have already discussed, it gives you what? Chlorine on reaction with water. Chlorine on reaction with water, it gives you HCl and HOCl. We have already discussed this reaction. Since chlorine on reaction with water releases nascent oxygen, therefore chlorine can be used as a powerful bleaching agent. It's a powerful bleaching agent because it can release nascent oxygen, right? If you talk about uses, bleaching powder, right, required in the manufacture of paper and rayon. bleaching cotton and textiles, in the extraction of gold and platinum. We'll discuss this in next chapter. In the manufacture of dyes, drugs, organic compounds, CCl4, chloroform, DDT, refrigerants, all compounds made is used. In sterilizing drinking water, earlier when there was no RO, chlorine used to be added in water to sterilize the water. Till now, it is added in small towns and villages. Preparation of poisonous gases such as phosgene. COCl2 is a phosgene. It's a poisonous gas. It can be prepared using chlorine. Tear gas, chloropicrin. Tear gas. CCl3NO2 is known as chloropicrin. It is also known as tear gas. Aansu ke gole. CCl3NO2. Mustard gas. Hitler used this in World War. Right? CH2S, CH2Cl, CH2Cl. Sulfur diethylene chloride. CH2, CH2Cl. This is your mustard gas. All these are uses of HCl. Right? So we'll do a question once we finish the right. So HCl ka properties, if you see, right? If you treat if you do the hydrolysis of salts, you'll again get HCl. Okay. So if you do the aqua regium, it is used C, HNO3 plus HCl. Right? So this forms mixed aqua regia. Where tear gas is used, you don't know where tear gas is used. In protest, they throw tear gas on you so that you run away. All those things. Many other places also. Where they want to scatter the crowd, basically. So HCl is a good acid. It can release H plus ion. Its Ka is this much. It reacts with ammonia to form ammonium chloride. It functions as a 3:1 mixture, act as aqua regia. 3 parts of HCl and 1 part of HNO3 are mixed. It forms aqua regia. The reaction is important. The reaction is very important. So gold, HNO3 plus HCl. HNO3 plus HCl में gold dissolves to form AuCl4 minus. The question will be, when gold is dissolved in aqua regia, what compound is formed? So you should say AuCl4 minus is formed. Similarly, platinum dissolves to form PtCl6 2 minus. And which gas is released? NO gas is released. Very, very important. Which gas is released? NO gas is released. Now it reacts. You should have done this reaction in double indicator titration also. So sodium carbonate ke saath, if you treat HCl, you have done this in lab test also. Carbonate in acidic medium will give you carbon dioxide effervescence. Similarly, sodium sulfide will give you SO2 effervescence. That is a major difference. Okay? Ha, it is there in class 10th also. Metal carbonates on reaction with acids. Right? It is used in the manufacture of chlorine, ammonium chloride, glucose, for extracting glue from bones, purifying bone black, in medicine and a laboratory reagent. So these are the uses. Oxo acids of sulfur, if you see, I have already told you this line. Fluorine forms only one oxo acid, that is HOF, in +1 oxidation state, known as hypofluorous acid. Whereas other elements can form the oxo acids like this. Whereas other elements can form the oxo acids like this. See. Fluorine forms only one oxo acid, HOF, hypofluorous acid, whereas HCl can form, chlorine can form HOCl, known as halic acid or hypohalous acid. Halic acid 1, halic acid 3, halic acid 5, halic acid 7. Hypohalous, halous, halic, perhalic. Easy to remember. Hypohalous, halous, halic, perhalic. So HOBr is formed, that is hypohalous is formed. HBrO2 is not formed. HiO2 is also not formed. They are not stable. So these are the all oxo acids formed by it. Fluorine does not form any except HOF. Okay. Now the question comes here is acidic character. What is the acidic character you get here? So acidic character is directly proportional to oxidation state, first of all. Okay. That means if they ask among HOCl, HClO2, HClO3, HClO4, What is the order of acidic character? What is the order of acidic character? So +1, +3, +5, +7. So you can see as the oxidation state increases, acidic character increases. Okay? Because as the oxidation state increases, its tendency to gain electron increases. It cannot lose electron. Okay? If it gains electron, it behaves as non-metal. Non-metallic compound form acidic compound. Non-metallic character increases, acidic character increases. Okay? Now, if they ask among HOF, HOCl, and HOBr, you will say it on the basis structure. See here, HOCl, HOBr. So you will say it based on. You will say it. You'll answer it based on the. You will answer it based on the atomic size, not on electronegativity. So as the size will increase, acidic character will increase, just like HF, HCl, HBr, and HI. So that finishes your group 16. Let's do some questions on it. Let's do some questions on it. Just a minute. Yeah. We'll start with this. You can do it yourself. Yeah, you can solve this. If chlorine is passed through a solution of hydrogen sulfide in water, the solution turns turbid due to the formation of. So what happens when chlorine reacts with hydrogen sulfide H2S? When chlorine reacts with hydrogen sulfide H2S, what happens? Monday, most likely Monday will start with next chapter, that is your metallurgy. So you can start voting on this question. You'll get sharp 1 minute for this. I have already told you what is the role of chlorine. Chlorine is a very good what? I think most of you are answering it correct. That's very good. Last 20 seconds. Right. So we are ending this on account of 3, 2, 1. तो देखो inorganic में सारे reaction by heart नहीं करने होते हैं. This is what is the problem of the people. They by heart every reaction. So if you go logically, you don't have to. Some reactions at least you don't have to. Chlorine is a good oxidizing agent. So it will oxidize S-2 to sulfur and form HCl. Okay. So you know sulfur is a colloidal solution. You have studied it in surface chemistry. Sulfur forms a colloidal solution. It is not soluble in water. It is insoluble in water. It is not completely soluble. It will form a colloidal solution, which will make the solution opaque. So it is free sulfur due to which it happens. Okay? Right. So we'll stop here. We'll continue some problem solving of this group. And group 18 will not take more than half an hour. So most likely we'll start next chapter on Monday only. We'll finish group 18 and start next chapter on Monday. ठीक है? अगर हमने P block 6 days में किया है तो metallurgy definitely we will finish it before, but metallurgy have concepts. P block don't have concepts, but metallurgy have some concepts. A Lingam diagram is there. Then leaching is there. So there are some concepts which you need to learn there. So definitely I'll teach it slightly differently. Okay? Chalo, let's move to your today's Kahoot is actually very interesting, very nostalgic. I don't know how many of you have watched it. I think most of you would have watched it. It's slightly nostalgic. So your game pin is 730842. 730842 is your game pin. Yes, from boards, your syllabus is over. From boards point of view, your syllabus is over. This is the last chapter from boards point of view. Nostalgic means पुरानी यादें याद आना, भूली बिसरी यादें याद आना, in other words. So from board's point of view, your syllabus is over, guys. This is the last chapter in your syllabus. It's not on 3 Idiots. Chalo, let's start. We'll get to know better. It's very old movie / something, whatever you can say. Chalo, let's start then. It's on very old thing. Something very old. Not DDLJ, not Sholay. Preksha, why you have such a bad face? Preksha, why you have such a bad face? I didn't get it. It's not on Suryavansham. क्या बात कर दी? चलो, let's start. Oh, got it. It's not on Ramayana. It's not on Spider-Man. Chalo, let's start. So when you were small, what was the most funniest song and most energetic song you heard in any cartoon? Most funniest, most energetic song. Chota Bheem, Doraemon. Chalo, let's. You have not heard this Jungle Book song? जंगल जंगल बात चली है हिंदी में. You have not heard? Chalo, let's start. It's on Mowgli. It's on Mowgli. Jungle Book. Easy questions, so answer fast. Who wrote the book that the film Jungle Book was based on? Who wrote the book that the film Jungle Book was based on? Who wrote the book that the film Jungle Book was based on? Yes, it was Rudyard Kipling. Rudyard Kipling. Vismay, Armoini, Ashutosh, Gaurav, Buzinga in top 5. That is correct, Rakshan. That is true. Go home and listen to this song again. What sort of animal is King Louis? You know King Louis? You remember King Louis? What kind of animal it is? थोड़ा बायोलॉजी आ गया, but ठीक है, it's fine. It's orangon. It's orangon. It's C. It's not monkey. It's not gorilla. It's not chimpanzee. I know people will do it wrong. It's C. सीख लो. First time देखा था. I know. Ravi Kiran, Ashutosh, Pradeep, Pranav, Varsha in top 5. Yeah. Image was there. They are smarter in their species. Yes. Right. And who raises Mowgli? A wolf pack, his mum, Baloo, a friendly mouse. This is the easiest question you can get. Who raises Mowgli? You cannot get anything easier than this. Yes, it was a pack of wolves who raises Mowgli up Bagheera. Ha, you can say that. Bagheera was the right word. Bagheera was the correct name. Right. And it is Ashutosh, Pradeep, Pranav, Preksha, Angry Preksha, Gokul in top 5. Let's move to the next question. What's the name of the littlest elephant? It was not there in movie, it was there in cartoon only. This smart little elephant. You see his hairstyle. His hairstyle is awesome, you know. So this smart guy, what was his name? Yes. He was Hathi Junior. His name was Hathi Junior. Right. So we have Ashutosh, Prekshar, Moini, Pradeep, Pranav in top 5. Pranav is finally back in top 5 today also. Pranav is having good week. Which country Jungle Book is based on? Come on, you cannot do this wrong. Which country Jungle Book is based on? Yes, and your answer is exactly. It's on India. I was hoping none of you will do this wrong, but still, you can see the amount of people who have answered A, B, C. My sympathy goes with you. Right. On the top, 4 out of 5. Yes, juniors perform better than you actually. 4 out of 5 correct. Hermione, Preksha all correct. Second. And Ashtosh all correct with a speed on the top. Pranav, Varsha were in the top 5. Well played all. Well played all of you. That's all for today. Monday, be prepared. We'll start the next chapter on Monday because group 18 will not take much time. Hardly half an hour, maximum half an hour, not more than that. Chalo. Take care, all of you. Have a good day ahead and may God bless you all. Finally, in podium, correct, Preksha. Interhalogen compound पढ़ा तो दिया अथर्व. XX dash, XX dash 3, XX dash 5, XX dash 7. कराया नहीं. IF3, IF7. Preparation and properties. Table is important. हाँ, preparation I can tell, but उसमें कुछ है नहीं. Like just combine the halogens and you'll get the compound. They're not big preparations in halogen compound. Right, Preksha. Correct. So let's end it here. Take care, all of you. Have a good day ahead, and may God bless you all.